Alright guys, let's talk about lesson 6, which is orbital diagrams. So orbital diagrams, what are they? They are picture explanations of how electrons are arranged within the atom. They show the order in which electrons are placed into the orbitals. Remember we talked about these, the S, the P, and the D. So here is a blank representation of orbital diagrams, and it shows the order with which you fill them. We're going to talk about it more in detail, and we're going to do a lab where we talk about it in extreme detail. But what you need to understand is that the energy increases going up, and you fill your S first, then your P's, and then you zigzag through. So let's talk about the energy levels of these orbitals. So as the number of electrons increases, so does the repulsion between them. So we have to remember, and we've been saying this a lot, like charges do not like to be next to one another. So what happens is that the different energy levels, the different orbitals in the same energy level do not have the exact same energy. So what does that mean? So in the second energy level, you have two types of orbitals. You have an s orbital and you have a p orbital. The s orbital is going to occupy a lower energy than the p orbital does. And these two are going to be in the same energy level, but a p orbital, a 2p orbital, has a slightly higher energy level. And you'll see the same thing happens when we go to 3s and 3p, and then 4s to 4p. The p's are slightly higher in energy level. So electrons in the orbital diagrams. So we're going to place electrons in the orbital diagrams, and they're going to be represented by an arrow. And the direction of the spin of the arrow is used to represent the electron spin. And there's only two allowed values of spin that an electron can have. It can have a positive 1/2 and a negative 1/2. So positive 1/2 would be an arrow flipping up, and a negative 1/2 would be an arrow pointing down. So there are some must-have rules for filling these orbital diagrams, and we're going to go through them. The first rule is the Hund's rule. That says that a number of electrons with the same spin is as large as possible within a specific energy level. So what does that mean? That means that if you had 3 electrons that occupied 3 orbitals of equal energy, so let's look in this picture, the 2p, you would have to put one arrow in each of the orbitals or in each of the boxes facing up first. So you would have to put an up arrow here, then an up arrow here, then an up arrow here before you can start pairing them up, because that will maximize the amount of energy and the electrons will have less repulsion between them because they're spinning in opposite directions. The second rule that you have to know is the Aufbau Principle. This means that orbitals are filled in increasing energy starting with the lowest energy level, and that's going to be the energy level closest to the nucleus, so the first energy level, which only has the s orbital in it. So we're going to start first with the 1s, and then we're going to fill up. The Pauli exclusion principle says atomic orbitals can only have 2 electrons, and they must be opposite spin. So that means that you, in each one of the little boxes for the orbital diagrams, you can have 2 electrons in them, and the 2 electrons need to be spinning in opposite directions. So one needs to be facing up, and the other one needs to be facing down. So let's look at some examples on how to fill orbital diagrams. So for period 1, let's look at hydrogen and helium. So period 1 is the first row on your periodic table. Hydrogen has an atomic number of 1, and so it only has 1 electron, and that electron is going to be found in the 1s orbital diagram because the 1s orbital is the lowest energy, and it's going to be facing up. Helium has an atomic number of 2 and has 2 electrons in it. So what's going to happen with helium is that you're going to have both electrons in the 1s orbital, one facing up and the other facing down. Let's look at period 2, which goes from lithium to carbon. So period 2, if we look at lithium, we have to place 3 electrons. 2 are going to go in the 1s, 1's going to go in the 2s, and as we go down this down the rest of this list, we are seeing that we're just adding one more electron. So this shows you a good picture of how they are filled. So what are some rules or guidelines when you're drawing these? First, you have to draw boxes to represent the orbitals. Then you have to place a pair of electrons with opposite spins to fill each orbital. Then you're going to place the remaining electrons in the last occupied sublevel or orbital, and you want to do it so that they're separate. So let's do a sample. Let's draw the orbital diagram for nitrogen. So first, draw boxes to represent the orbitals. So here are the boxes, okay? Nitrogen has an atomic number of 7, which means it has 7 electrons. Second, you need to place the pairs of electrons in the last occupied sublevel in separate orbitals. So, we have placed 2 in the 1s, 2 in the 2s, so that means that we have 3 electrons that are going to be placed in the 2p. So we're going to place those in the 2p. And so when we're finished, this is what our electron orbital diagram is going to look like. And remember, each one of these 2p orbitals needs to have a up arrow first before we put them down arrow. We can't pair them up. So let's look at an example. Another example. Draw the orbital diagram for boron. So boron has 5 electrons total based off your periodic table. So let's place those 5 electrons. So 1, 2, 3, 4, 5. And that's it. Let's look at another example. What if I were to ask you to draw the orbital diagram for magnesium? What would that look like? So again, we're going to start off with our blank orbitals. And here you could see that we have to, for magnesium, place 12. So I'm going to start with the lowest energy level and work my way up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. Now you try. Draw the orbital diagram for aluminum. Pause the video and unpause when you're ready. Great, guys. Well, what did you come up with? So we're going to start off with our boxes. And now let's fill them. Aluminum has 13 electrons that we need to place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's what you should have come up with. Let's look at check your understanding. We're going to go over this first thing tomorrow, but in your notes, I want you to try and draw the orbital diagram for calcium. See you tomorrow.